Hello, today in this lesson we are finishing up our study of normal distributions. This is part 3. This is part 3. So we've looked at the characteristics, we've looked at the empirical rule and using that to determine percentages of data. And now we're going to use the empirical rule to determine numbers of data, and I know that's really kind of not crystal clear the way that's worded, but you'll understand it when we do it. So we're focusing here. If you were able to really understand this from the previous lessons, from the previous videos, then this part 3 here, is going to be a piece of cake. Alright, so just to remind you, the normal distribution, what you get is data. There's a mean right here in the middle. That's the mean average, and most of the data values really center right there, right near the mean. And then as you get further away from the mean, either greater or lesser, you get less and less data values piling up there. So anyway, as it turns out, when it's a normally distributed set of data, there's 68% of the data values fall within 1 standard deviation of the mean. 95% falls within 2 standard deviations of the mean, and 99.7 falls within 1, 2, 3 standard deviations of the mean. Okay, so we've talked about the percentages. We've talked about being able to break these percentages down into each of their individual columns. We spent a good amount of time in the previous lesson doing that, and you can see that here in this particular curve. Once again, you can just memorize these numbers. And there was one more right here. Does anybody remember what that percentage was? Yes, sir? 0.15. 0.15 is correct. 0.15% falls outside, well, it falls to the right of the outside of 3 standard deviations from the mean. So 0.15 on this side, and also 0.15% on the outside, on the left side. Okay, so let's look at an actual problem here. This is from your notes. I've moved the wording around a little bit if you've got notes that look slightly different than this. But it says, the wait times on a computer helpline average 4.2 minutes. Okay, so that's important. It also says the standard deviation is 1.3 minutes. That's important. Notice it says sketch the normal curve. So this problem is all about normal distribution. So we want to sketch it. And by the way, here in this particular problem, this is going to be a summary of all 3 skills that you are responsible for on the upcoming test. So this skill right here, this is Unit 2B1, as I have labeled it. So you're sketching the normal curve, showing the wait times at 1, 2, and 3 standard deviations from the mean. Then, after we get done sketching it, we're going to ask ourselves what percent of the people wait longer than 5.5 minutes. And then what we're really focusing in here today on this lesson is how many people. So this is about percentages. This is about actual numbers of people. Okay. So let's draw the curve. If you haven't drawn it already, I would encourage you to take a moment right now. If you're watching the video, you can pause the video and try to go ahead and get the normal curve drawn completely using 1, 2, and 3 standard deviations from the mean. Okay, so I'm going to go ahead and draw the normal curve. We're going to label the mean right here in the middle. It's 4.2 minutes. The standard deviation is 1.3 minutes, so I add 4.2 plus 1.3 and I get 5.5. And add another 1.3 and I get 6.8. Add another 1.3 and I get 8.1, right? Okay, on the left side, we're going to subtract 1.3, so that would be 2.9. Okay, 1.6, and then 0.3. All right. So I know that I have 68% here. I know that I have 95% falling within 2 standard deviations from the mean. 1, 2, 1, 2. So within 2 standard deviations of the mean falls 95% of the data. And lastly, 99.7% of the data contains or is contained within 3 standard deviations of the mean. Okay? Now this right here is what I'm expecting of you for this first skill. If you went above and beyond this, fantastic. If you labeled this as being 34, and this being 13.5, see, I don't have it memorized. I don't know, that's what you guys got to do. The next one's what, 2.35? Yep. And the next one is 0.15. If you did that, that's a little bit extra, and I'll accept that. So you should probably go ahead and label both sides. Okay, and about what percent of people wait longer than 5.5 minutes is the question. Okay, so this right here, we're finished now with Unit 2B1, sketching. The purple is not required, but if you did that, then that's even better. It's even better for you. It makes these other 2 skills go by like that. So let's go ahead and answer the question. About what percent of people wait longer than 5.5 minutes? So what I do here is I'm just going to look right here at 5.5, and I basically want to know what percent is this. So that's real simple. If I've done all that other work, if I've memorized those, I'm just gonna add this up. So 13.5 plus 2.35 plus 0.15, and I add it, and I get 16 even. Great. 16%. So just to set the problem up again. You got some problems with your computer, you call in to talk to one of the people to help you fix it, and so
I got 16 point. Never mind. You just round it
Oh, did we round?
out. I got 16.15.
Okay, in your calculator, did you type in 13.5 plus 2.35 plus
Never
0.15?
mind, 2.5.
There you go. Yeah, that's the one that most people would mess up on, is this one. It's 2.35, not 2.5. All right, good point. Now, anyway, so I call in, the average wait time is 4.2 minutes, but does everybody wait 4.2 minutes to get a response? No. Some people wait less, the lucky ones. Some people like me, feels like I wait an hour and a half sometimes. The standard deviation is 1.3 minutes. So what percent wait longer than 5.5 minutes? 16%. Now, the next problem here. How many people actually wait longer than 5.5 minutes? Here's how you do it. How many people were, now a queue is also a line. It's like you're in line, you're waiting, okay? So take a number and sit right there and wait. All right, so there's 500 people in the queue. So if we know that 16% of the 500 will be waiting longer than 5.5 minutes, then all I have to do is just take 500, multiply it times. You've got to change you got to change the percentage to a decimal. So it's 0.16. You move the decimal place 2 places over. And you just multiply that in your calculator. What do you get? 80? 80 people wait longer than 5.5 minutes. Ta-da! Okay, so this right here is the purpose of this lesson. What did we do that was new? Nothing. We had all this extra stuff. There was only one small little thing that you had to do, and that was take the percentage from the previous step, change it to a decimal, multiply times the total number of people that are involved in this study. Okay? We could probably look at another question or two. Let's go ahead and do one more, and then we'll wrap this lesson up. The grades on a test are normally distributed with a mean of 82, standard deviation of 6. 345 students took the test. How many students passed? And that is scored 70 or higher. Okay? So everybody take a moment, draw the curve, figure out the percentages, figure out the number. I'm going to give you a few minutes, and if you're watching the video, I would suggest you pause it and come back to us after you've given it a shot. Okay, so we took a moment to go ahead and draw it out. I'm going to do it now. This. Oh boy. Here we go.
Did you get one of
82 is the mean, standard deviation is a 6, so 82 plus 6 is 88. 88 plus 6 is 94. 94 plus 6 is 100.
Oh my gosh.
Sure.
The bottom one? It is right. I literally did.
Davis? Bradley? Davis? Brittany. Brittany. Should check it out.
Is he in the office? Okay, all right.
Click.
That's for a few minutes.
You can just go. I'll pass for you. Okay, so did I get these numbers right? Oh man, that was all during the recording. Okay, sorry if you were watching the recording. That was a waste of your time. All right, so 82 minus 6 is going to be 76. There we go. Minus another 6 is 70. Minus another 6 is 64. 64. Okay, so now the percentages. I got smart and I memorized all these percentages because I know it's just going to be more helpful that way. So this is 34. This is 13.5. Maybe I didn't memorize them. All right. 2.35 goes right there, and 0.15 goes right here, and we'll double it on the other side if need be. This question says the grades on the test are normally distributed with a mean of 82, a standard deviation of 6. 345 students took the test. How many students passed? That is scored a 70 or higher. So I'm just going to highlight where's the 70 or higher. It's right here. So I want to know all the percentages that fall right here in this section. Okay, so all I need to do is just include this 34% right here and this 13.5% right here. Add all these numbers up and I have my percentage. So 13.5, 34, 34, 13.5, 2.35, and 0.15. Add those up. Somebody with the magic calculator, what'd you get? 97.5. Okay, so now with this number, now I'm going to ask, or I'm going to answer the question. There's 345 students in the class. They take the test. What percent of them pass the test? 97.5. So I'm going to change that to a decimal, 0.975. Multiply it. And I heard some of you guys had a decimal answer, so let me just go ahead and give that to you here. 345 times 0.975. And my calculator says 336.375. Now, what does this mean? We're talking about people here. So we want to round. So what makes sense? Should we say, well, I mean, obviously it rounds to 336. We can count on 336 people to pass and a third of another person. So Nick, do you care to be that third of a person? Sure. 0.375? Okay. Nick's our volunteer. So what?
How do you have no? Then why does it come out? Because it's just a problem. No, but that's...
Just round it. It's just round. It's not an exact answer because it's not an actual, like, it wasn't actually done.
Okay, so approximately 336 people, students, passed the test. That was almost everyone, but there were a few that may need to retake. Carter. All right. Any other questions here on this skill? All right. Well, thank you for hanging in there. This skill once again was using the empirical rule on normal distribution problems in order to determine numbers of data, specific numbers of data. Obviously, we have to know how to do percentage of data before that. So thank you for watching.